Right. Hello, everyone. Welcome. We're going to be getting started in just about 1 minute. We have a few housekeeping items up on the slide in front of you. For instance, we're going to have all the lines muted while the session's being recorded, and then we'll be able to share that afterwards. We'll have a Q&A option. You can submit your questions to us, and we can answer them either during the call or after the call. And we will be distributing this recording afterwards as well. So if you have any problems, there's some good troubleshooting tips there, and we will start it in about 1 minute. Thanks.
Thank you, Dave. Welcome, everyone. Yeah, these ones are better.
Yeah.
If my opinion helps you.
Good. All right. So why don't we go ahead and get started? So first of all, I want to welcome everybody to today's Splunk Tech Talk. I'm Dave Hickman, and today we're going to be diving into how to unlock database monitoring within Splunk Observability Cloud. Because for too long, the database has been a black box for site reliability engineers and developers, leading to mystery days and endless war room finger pointing. But today we're changing that. We're going to show you how to gain total visibility across your entire database fleet using AI and full stack correlation to turn hours of troubleshooting into seconds of action. But before I get started, I want to just make a quick note on our safe harbor statement here. Today, we'll be sharing some exciting roadmap items and future innovation. And just a reminder that these are forward-looking statements. And as always, our plans and timelines are subject to change based on market condition and development cycles. So bear with us on that. Okay, let's do some quick introductions before we get in there. I'll start it off. Again, pleased to meet you all. My name is Dave Hickman. I'm a product marketing leader here at Splunk, but my observability journey actually started back in 2019 when I first joined AppDynamics. It was after Cisco acquired AppDynamics, but before AppDynamics was merged into the Splunk Observability Group in 2024. So for the last 6 years, you could say I've been living and breathing observability, mostly helping customers and partners make sense of where this technology is headed. And my favorite part of the job is probably taking this complex innovation and translating it into simple, big picture value for your teams. I was going to share a background today, and you might have noticed that I have quite a bit of hi-fi gear behind me. So just as a personal fun fact, I am a huge music fan. I've got about 1,500 vinyl records taking up space in my office. It's probably better that I have the virtual background. So I'm going to hand it over to my partner, Akshay. Akshay, why don't you introduce yourself?
Thank you, Dave. Welcome, everyone. Good morning, good afternoon, or good evening from wherever you are joining us from. Thank you for taking out the time. Hopefully this is worthwhile for you. And interestingly, Dave, I didn't know you started your journey in 2019. Just like Dave, but anyway, before we go there, my name is Akshat Grover. I'm product manager for database monitoring at Splunk Observability. And like Dave, I started my journey with AppDynamics as well in 2019, actually December 2019. And I joined as an engineer. I was an engineer in the Kubernetes monitoring team. We were just going GA with it. And so after 2 years doing that, I became a product manager for database monitoring. And I've done a couple other things as well, like network monitoring and cloud monitoring. So like a good spread in observability. So yeah, now database monitoring somehow stuck with me, and I'm excited about where we go with it, especially now with AI. I think, Dave, as you mentioned, I think the space is ripe for, like blowing up. So I think there's a lot of things we can do
Yeah,
differently with AI now. So yeah.
awesome. And I know we're going to showcase some of that today. Curious just in terms of your background, having worked on database monitoring for a while. I know this is new for Observability Cloud,
Yeah.
but it's not new for App Dynamics and it's not new for you. So I was wondering if you could kind of share some of the insights you gained while supporting our, thousands of customers on App Dynamics before bringing that experience here to Splunk.
Yeah. I think one of the key learnings for us, even when we were trying to look at the value of database monitoring with App Dynamics was, right, it's not a new space. Database monitoring has been solved like many years ago, right? There are many DBA tools, many like point solutions that have solved database monitoring, right? But the core value prop actually lies in the correlation. I think, Dave, you touched upon this in the beginning of your introduction, right? To think of it, how I explain to my teams how to think of correlation, right? Think of, you have two sheets in Excel and you're trying to correlate data manually, right? You're trying to relate one column with another column, and without VLOOKUP, it's a very hard thing to do, right? So that's what correlation is. And App Dynamics helped solve that. You had application monitoring, then you had database monitoring. You could easily switch between these two. You could identify dependencies. That's the core value prop of an observability platform. And that's the core value prop even with database monitoring and observability cloud for us. So that's like a core learning and a core pattern, because without that, it's at scale, it's very hard thing to do manually, right? So that correlation piece is really the key.
That's great. Yeah, I know
Yeah.
the traditional evolution, the correlation comes later, but even in our first release on Observability Cloud, that's baked right into the solution.
Yeah.
So that's cool. Well, look, now that you get the chance to do it all over again with a more modern cloud native platform to build it on,
Yeah.
what are you going to do differently this time around? What sort of advantages can you take advantage of to provide more value to our customers?
Yeah. One of the other learnings, kind of an observation from App Dynamics users was, it was not really the DBAs who were using our tool to start with, right? What happened was, it was really the support teams, the SREs, your application engineers, or your platform teams. I think there are a bunch of names that we call the same teams or same roles in different industries. But they were actually the ones who were looking at full stack and DBMon as well. But they are not the ones who truly understand database monitoring, right? Like they are not very well versed with databases, right? It's a very complex domain. So one of the things that we were even trying to do in App Dynamics, which we were not super successful with, was how can we make it easy for our users to kind of understand what's happening, right? Identify patterns easily, even identifying if I should add an index. Should I just add an index? Why should I add an index, right? What performance impact will it have? Like identifying those problems and truly triaging those. And that requires domain knowledge, right? But our actual users were not the ones who had that knowledge, right? So one thing that we are now aiming to do with Observability Cloud, Splunk Observability Cloud, is how can we be recommendation first, right? And we are very early in those stages, but that is something that we're really excited about. Like, how can we make it recommendation first, so that those users who don't have as rich domain knowledge can also try to solve the issues on their own.
That's awesome.
Yeah.
Well, I can tell we've got the right person here at Splunk taking care of database monitoring for us, because that experience
I hope so.
working with customers is just hard to replicate from scratch.
Yeah.
Okay, so I think let me see. Before we kind of get into the agenda, we wanted to get some information from you guys, the audience. How many of you are currently using Splunk Observability Cloud for your observability solution today? It's a pretty simple yes or no question. I imagine a lot of you guys are, but I'm curious. Are there some AppD customers in the room? Are there some prospects or other people in the room? If you wouldn't mind just clicking on your response here, we should get some insight in a few more seconds. Looks like we've got about 20% is voted already, 30%. Looking good. Can you see the responses, Akshit?
Yeah, I think 18 of 60, 30%. I'm
Okay.
not, I think we'll have to do next. Do you
I
want
have
me
to
to do
do
that?
next to see what the results are. Okay, let's take next. Okay.
Oh, good
So we've
mix.
got about
Wow.
about 30% are already got their foot in the door with Observability Cloud, and another good chunk of people who are interested in exploring it a little bit more deeply. So I think we've got the right audience. Keep us honest. Keep those questions coming to us.
Yeah.
So let's talk a little bit about what we're going to cover today. We do have a lot to cover, but we want to keep this session practical, and we want to keep it focused on the challenges that you're actually facing. So we're going to start today by setting the stage. We're going to look at database monitoring in the modern era, and why the old way of doing things just isn't cutting it in today's complex environments. Then we're going to introduce you to Splunk Database Monitoring and show you how we're bridging the gap between apps and data. But we know you're here to see the tech and not just the slides, so we've carved out plenty of time for a live demo. After that, we're going to take a look at our roadmap and dissect some of our key investment strategies, give you a sneak peek at some of the innovations that are in the lab today, including where we're headed with agentic AI. And then we'll wrap up with some next steps, how you can get started. And of course, we're going to be saving time at the end for all your questions. So let's just jump right in. And I'm going to pass the baton to Akshit to get us started.
Awesome. Thank you. Yeah. Before we kind of talk about challenges, right? I think it's very important for us to understand like what the problem space is, right? Let's take a step back and look at how as an industry we have evolved, especially when it comes to operations, right? The digital economy has grown. That means the digital applications have grown. The scale is pretty massive now. Thousands of microservices. There are customers we have like with 70,000 hosts. Can you imagine, right? And when the applications scale, the scale increases, the operations have to scale as well. And if you look at broadly the patterns to scale, right? The first stage is you have more people for the same job, right? You have more people, now we have more hands to do the job. But slowly you start to realize that, oh, that's not efficient, that's not scaling. You start to see the limitations there as well. Now people have to talk to each other, there is no shared context, they have to maintain knowledge bases and whatnot, right? So you realize, oh, maybe now not adding more people is helping me. Maybe what I should now start doing is let's merge the roles, right? So the same people now will have more responsibilities. And we have seen this happening like DevOps, SREs, now platform engineers. There is this customer we have, they have some concept of like full stack platform teams or full stack operations teams, right? So, and you start seeing that now. Then you realize, oh, even that is not scaling further. So then what you realize, for us to actually make more people, the same people own more responsibilities, you need the right tools. So you employ them with the right tools. That's where observability comes in, right? And that's what if you have noticed the pattern or the trend in the last 5 to 10 years, observability has really grown. Like I remember seeing news, 3 years ago, everyone was building an observability startup, and now you see all those everyone, like there has been a lot of acquisitions as well, right? So observability is truly a scale problem to help us become more efficient at scale, right? Databases have been a little late to the party, but they are here. Right now, if you see, I'm sure people on the call, you have the same, you notice this in your kind of deployments as well. It's not the same state when it comes to database landscape now. You don't have just Oracles or SQL servers or MySQLs. You have all of those with PostgreSQL, MongoDB. So, and it's not just SQL, it's NoSQL as well. And it's not just on-prem, it's not self-hosted, it's on the cloud as well. So now like, it's not just the number of databases have grown, but also the types of databases have grown, right? And to kind of deal with that scale, it's not just about having more DBAs for the job. Now you also noticed, and we have some customers who have validated that for us. And this was an hypothesis when we started 1 year ago, or even with App Dynamics, right? That now you have SREs or the platform teams kind of owning, taking the shared responsibility. Now they are owning database operations as well. So the roles have improved, or the roles have sort of evolved, but the tools have not, right? So observability, AppDynamics was one of the first tools that kind of realized this early on and had database monitoring in a full stack offering. And now you see there are other vendors also trying to do the same, right? So that is where that's the core thing about um, why we need database monitoring in context observability. It's truly a scale problem. If you're running just one DB, you're all good. You don't need an observability monitoring tool. But if you are facing this problem, and you face, okay, you have disparate teams, your teams have to collaborate with each other. You realize, oh, my tools are siloed. There's no shared context. It's very hard for people to kind of understand what's going on. There are back and forth and stuff like that, right? So that's you are in the right place. That's what we are trying to solve for, right? And I don't think we have to kind of uh, say why. I think everyone on this call who has joined kind of understands what it means for the business, right? If we don't make our operations, if we don't scale our operations efficiently, if we don't employ the right tools, empower people with the right tools, the business suffers, right? And not just business, there is lower trust in the system. Like your teams don't trust each other, right? There's no fun in the job, if you will, right? So, and that has long-term impact. So in a way, we are solving for not just business but also making your teams happy. So yeah,
Great.
that's
great,
the core
thank
problem
you.
statement. Over to you, Dave.
That resonates with me absolutely. Let me see where we are. So today, we are introducing. In fact, we released this back in October, but we're making sure that we can bring the news out to you guys. And we're introducing Splunk Database Monitoring. So if what Akshat talked about resonated with you, if you have complex database estates with multiple engines, if you really need unified observability across your entire stack, which who doesn't? If it's taking you too long to solve database-related application performance problems, or it takes too many people in your war room to solve those problems, then you're in the right place today, because we're going to be talking about how do we solve for a lot of those things. So Splunk Database Monitoring is a new capability for Splunk Observability Cloud, and it helps you spot and resolve slow and inefficient queries across your entire database fleet with execution plans and rich query metrics, so that SREs, application and database teams can all work together to trace application issues to specific queries for faster analysis, so you can see which applications are driving that load on your databases to help you optimize resource usage. And of course, AI-powered recommendations are here to summarize and improve queries with ready-to-run code snippets. Let me show you a few of the key capabilities that we're pretty proud of. Starting with the ability to identify performance bottlenecks. So Splunk Database Monitoring can help you identify performance bottlenecks, which is a primary challenge for DBAs and SREs, is in trying to identify problematic queries. And with Splunk Database Monitoring, we provide deep insights into query performance. So we can show you which queries are running slowly, which queries are consuming the most CPU, IO, or memory. And we can show you their execution plans and wait events. And it's this proactive identification that allows you to optimize your database performance before it impacts your applications or your users. So we can help you move beyond just, is the database responding, to, is the database performing optimally? So I love that we're kind of leading with that preemptive or proactive approach here. Next is how Splunk Database Monitoring helps you troubleshoot slow and costly queries with execution plans. So once a slow query or database slowness is detected, then the next step is efficient troubleshooting. And Splunk helps you quickly diagnose the root cause by correlating performance metrics with other relevant events. For instance, is this a specific query? Is it a resource contention? Maybe it's a sudden spike in IO or CPU usage. Is it due to a locking issue? We provide the granular control and contextual information needed to pinpoint the problem whether it's a poorly indexed query, an inefficient schema, or an underlying infrastructure issue. Finding the root cause of inefficient queries has never been easier with Splunk Observability Cloud. Another great thing is, as Akshat mentioned, that we're leading off with is how Splunk Database Monitoring also correlates database performance with application and infrastructure metrics to help you see the bigger picture. It's not just a database problem. This is an application problem. This is a user problem. This is a business problem, right? So this is where the full stack aspect comes in, and it's incredibly powerful because I think we all know database issues rarely exist in isolation. So a slow query might be triggered by a specific application deployment, or maybe a database server is struggling due to underlying infrastructure issues. Splunk now allows you to correlate database performance with application traces, so you can see which application services or endpoints are executing the slow queries, where the impact is. And it also correlates with infrastructure metrics, so you can understand if a database host is experiencing CPU saturation or memory pressure or disk I/O bottlenecks. Maybe that's what's causing the performance challenge. In just a minute, during our demo, you'll see how to trace application slowness and how to determine which business applications are being affected by these slow queries. But not before I share one of my favorite parts of this, which is how database monitoring doesn't just find and troubleshoot problems. We can actually help you fix them. With our new SQL optimization, this is vital for scaling, not just functioning. You can improve your queries to help improve your response times, reduce resource consumption, lower your cloud costs, and even prevent transaction locks. See, Splunk's generative AI revolutionizes this process by replacing manual analysis. It can rewrite complex queries for efficiency. It can translate cryptic execution plans into plain English, and even suggest predictive indexing. And this empowers teams to resolve bottlenecks instantly and ensure that long-term database stability as your data volumes grow. So that's some pretty cool stuff there. But we know that you're really here to see the demos. So all 4 of those use cases that I just described to you, Akshat's now going to show you that database monitoring in action.
Awesome. Yeah, now let's take it from slides to actually the real world. And we want to do a live demo. So we'll start with the live demo. And it will be helpful if everyone on the call kind of prays to the demo gods, if you will. So you never know with the live demo. We tested it. It was working an hour ago. So let's see if it works now. Can you see my screen, Dave?
Yes, I can.
You can confirm that. Awesome. Great. So I think based on the poll, at least 33% of you are Observability Cloud users. For the rest of you, this page is the landing screen of our Observability Cloud. You can see all the active alerts across your entire fleet applications, infrastructure, and whatnot. But today, the focus is database monitoring. So let's dive in. The way to access database monitoring is you look at APM, which is in a way representing applications. And because databases are closer to applications, so database monitoring kind of lives under this menu. You click on overview. And this is what we call internally like an estate view, and where you can see not just a particular type of database, but any database that you are monitoring. Today, we have support for SQL Server, Oracle, and PostgreSQL. So you see all those database instances listed here. And when we go to the roadmap, you'll see we'll be adding a lot more database type support as well. So this truly becomes like an estate view. And this view will become a lot better, a lot fast. Like things like, what we'll be adding is here active alerts, similar to what you saw on the home screen, where you can see which database instances are experiencing active alerts, so you can directly dive in. So this truly becomes like an estate view of sorts, where you can have a bird's eye view of your entire database estate. Let's say you're interested in a particular DB, you dive in, you drill down, and this, let me increase the time range so you can see a lot more colors. But this screen the idea is on top, you see active sessions split by wait states, right? So if anyone knows about database monitoring, right? Wait states brings us closer to just knowing what wait states my queries are experiencing it brings you closer to what the performance bottleneck might be. In a way, it brings you closer to root causing. So which is why we wanted to keep it front and center, like active sessions. What are the sessions what are running on the DB? It kind of gives you a view of your load on the database and what type of load is it, right? Is it like a heavy memory load? Is it maybe like, like memory allocation? Is it high CPU load, right? So you can kind of get that profile in. And let's say you see a spike here, you can select it and you can drill down. So it changes the time range. You can clearly see which queries, because I've zoomed in, you cannot see the wait states, but you can see which queries were executing at that point in time and which queries are kind of contributing to that wait state or that performance bottleneck on my database instance. And you can see you split those by wait states and stuff like that. Let's say let's say you're interested in this query. You drill down and you see the execution plan now. And in that execution plan, if any, just to kind of introduce what execution plan is, it's basically how a database engine or the steps a database engine takes to execute that query, right? In a way, it's like your trace, like which application services are required to fulfill an API response. Its execution plan is something similar, but within the realm of a database, right? So you can see the execution plan this query has been using, and a query can have, if you're looking at a particular time range, there can be multiple execution plans, and everyone knows that um, an execution plan change is also can also cause performance bottleneck. So you could see multiple execution plans here, identify any query execution plan regression issues and stuff like that. And but most importantly, you can view the execution plan itself, and you can. What we have tried to done is we've tried to do is add cost badges here to kind of make it easy for you to identify which part of the execution plan, or in a way, which step of the query is a problem, right? So you'll see high cost means high execution time in most sense. So here you can see it's using a cluster index scan, but why is it not using cluster index seek and stuff like that, right? So it helps you easy to kind of bring you more closer to root cause and how can I optimize this query further, right? Another part is you can also see how this query has been performing over time. What are the waits that this query has been experiencing? What are the executions, total duration, like all the other normal metrics that we average duration, all the cool stuff. But even this is one thing that I want to call out is this is a normalized query. This is not a query execution. It's basically an aggregate of all the query executions this query has had in a given time range. So this is an aggregate view. But what if 99% of the executions were fine? There was one execution that took the most amount of time, right? So that's where query samples sort of come in, right? You can see you can have view into the particular execution of a query, right? Which client the query came from, which user the query came from, which session ID, which part of it took the most amount of time, right? You can kind of drill down further. You can see a lot more details about it, a particular execution plan for that particular execution and stuff like that, right? So you basically went from an aggregate view from a database instance into execution to a particular normalized query to a particular execution of that query and to a particular execution plan, right? So in a way, if you notice, you are getting more and more closer to the root causing, right? But another part is, what if you realize, oh, this query is a problem, but it looks like the query is not written the right way, right? So that's where kind of traces come in. You can clearly identify which traces this query has been coming from, which application trace. You can drill down into a particular trace. It opens up the trace view in the application performance monitoring product that we have in Observability Cloud. So now this is the correlation piece we were talking about, right? And one thing now we'll be adding here is which services, right? Because now we know the trace, but which services it's coming from, which business workflows it's coming from, and stuff like that. So this is like the atomic view. Trace and span ID is the atomic data set or the metadata we need to kind of make it happen. So this is the first iteration that you see here, but we'll roll it up to services and business workflows on the application side, so you can clearly identify the dependencies. And at the same time, you can also go back. You can see, okay, this is a different trace of the same application. Let's say you identify this is an application known as this is a slow trace. You can drill down from here to the same view, because now you can see, oh, it looks like my application is slowing down or this is a slow trace because of a slow DB span. And why is my query slowing down? So you can directly go from a trace view to the application, to the database monitoring view and execution plan and stuff like that on the DB1 side, right? So that's the bulk of it. And now over to, let me take a different query or a longer query, which is more complex. Now over to the Dave's favorite feature, right? AI recommendations, right? Now, one thing is, one of the most common feedback that we got from the users is that optimizing queries is the bulk of the job, right? And it requires a lot of esoteric knowledge. So one thing we wanted to experiment with was, with AI, LLMs are helping us doing knowledge work in a way, right? So can we apply the knowledge LLMs have to help us rewrite the query? So that's what we did, and this is what you see here. You can see your original query. We give this query along with the execution plan to the LLM, and the LLM help us rewrite it, right? And it gives you why it did what it did. It gives you, okay, it looks like your execution plan had a sort operation which was using 61% of the cost, right? So in a way, 61% of the execution time, roughly, right? So it gives you, okay, let's replace it with this. It'll help you with optimizing it further. So it helps you rewrite those queries in a most optimized manner. And it's still experimental, but it does the job. Right? And gives you further things like, missing an index and stuff like that. So there's a lot more work to be done on our side to kind of give you better recommendations. But as we said, right, that's one of the core things that we learned from AppDynamics, like how can we make this recommendation first? So you'll see a lot more changes once you start using it, that, okay, there are a lot more recommendations coming in. So yeah, that's it. That was the demo. Looks like the demo gods were with us this time.
That was great. Great demo. I love you gave us a really good overview of starting with the database, but also you can start with APM and see an issue in an application and then follow it all the way down to the database too, right? Excellent.
Okay.
So let's see where we go in next. Literally, where are we going next with database monitoring? So what we've done already is, you can see, for the first release, is we've already built a powerful foundation. We're now accelerating our investments to define the next generation of database observability. And our roadmap is focused on delivering best-in-class resilience through these 4 strategic pillars. First, we're building universal coverage by rapidly expanding our support for more database vendors and more database types so that we can cover your entire database landscape. Second is, we're extending our precision troubleshooting by moving, beyond some of the simple stuff that you've seen here today to even deeper, more granular diagnostics to provide expert insight into database performance problems. We're integrating it deeper into the Splunk Observability platform to provide that unified observability across APM, infra, and database. We're seamlessly integrating these insights, again, throughout Splunk Observability Cloud, all to help unlock faster mean time to resolution and quickly identify and minimize business impact. And finally, we're building AI native operations. This is something that's really important, not just for us, not just for Splunk, but all of Cisco, is really leveraging agentic AI to automate root cause analysis and remediation to help eliminate the manual toil associated with maintaining these complex applications.
Yeah.
So why don't we take a look ahead? And Akshay, maybe you can give us a preview of some of the breakthrough innovations that are currently in the lab today.
Thank you, Dave. So yeah, these are like the key investments, as you pointed out, right? So let's take a look at the some of the key features in each of these buckets, right? So one thing is to start with. So today in the demo, you saw our focus has been around query monitoring, because that's like the workload view of what's running in the DB, right? But another part is, okay, if a query is part of a stored procedure, right? And that's like database code. It's not just coming from application. It can be stored procedures within the DB. So one thing that we want to, that is almost done from our side, and we'll be releasing soon in a couple months, is stored procedure monitoring. Where you can identify similar to how queries, you'll see a stored procedure list view. You can identify slow and resource intensive stored procedures, plus which queries are part of those stored procedures, and and troubleshoot it further. So that's one thing that's in the works, and we'll be releasing it in a couple months. It's going through the testing phase. And apart from that, and this is where the depth kind of aspect of the roadmap theme comes in, is it's not just about query monitoring. If you identify, there is a slow query. It's slow because it's experiencing excessive locking. Why is it experiencing excessive locking? Right. So that's where blocking session comes in, and this is also in the works, and this will be available sometime around July timeframe. As you can see, is easily identifying the head blockers, like what queries block what queries, and identifying those patterns and troubleshooting those further. So blocking session is, I think, is also one of the very common, or after slow queries is one of the most prominent. Excessive blocking is one of the most prominent issues that people face. So this will also be a good one to kind of get more closer to the depth and provide more depth to the DBAs and SREs and others. Now, this key feature is part of your platform advantage side, sort of a roadmap theme, right? Like how can database monitoring is not sitting in a silo. It has to tie to the whole full stack observability to kind of goes back to how can we make our operations scale efficiently, right? How can we make people more efficient in their jobs, and as a result, make them more happy is service map to database monitoring correlation, right? So in an application view, for people who use Observability Cloud, or if you have used any observability tool in the past, on the application slide, you can see, you can detect an exit call from an app to an infer database, right? So can we directly drill down from, not just from trace, but also from that application service directly to the database instance, right? So that is something that also is in the works, not just at a trace level, but also at a database instance and service level. And another AI feature, whenever I say it, I try to demo it. I'm not sure if anyone have faced this, but all the buzzwords sort of become cringe because of the overuse. So I try to kind of present it by not feeling like that way. But the reality is it's true, right? AI has to add a lot more value, right? So one thing that we are experimenting with, and I'm using that word very cautiously, and if you see, this will be in the like an alpha stage release in April, is can we use LLMs to not just rewrite the queries, but also help us all the data that we have in the system, execution plans, query performance metrics, query samples, traces, and stuff like that. Can we utilize LLMs to start summarizing all that data and help us understand why a query might be slowing down, or why a query is taking so many resources, right? So it's you can call it troubleshooting, but it's really a summarization problem, right? Even troubleshooting is summarization, right? So we are starting with just, okay, these two common use cases around slow queries and resource intensive queries, right? So we'll start with that. But once we do that, we'll not only tie it back to the whole system, like Dave mentioned, around starting with application and infrastructure. So there's something called as a troubleshooting agent that is being worked on at the whole platform level. So we'll tie it back to that, right? Plus also we'll expand it to more use cases, right? High CPU usage, or stored procedure. Why is there excessive blocking and stuff like that, right? So this is experimental, just to be very clear, but this is something that can add a lot more value and can give us a lot of success. So those are some of the key features that are being worked on and will be released in the couple months. But this is not just it, right? There's a lot more other things that are being worked on. I know someone in the chat has a question around what database type do we support today. So today we support SQL Server, Oracle. PostgreSQL is already out. We did this before we did this slide before the release came out. So PostgreSQL is already out. Some of the other database types that we're working on is MySQL and MongoDB. So these, as you can see, the timeline around MySQL and MongoDB is around, again, the few months timeline. And around the depth, as I mentioned, it's not just stored procedure and blocking session monitoring. Those are ones that are coming out in the next few months. But another ones, very important ones, are like index utilization monitoring, right? As I mentioned at the beginning, it's not just about adding an index, but if you add an index, what does it do to your system, right? So that's where index utilization monitoring comes in. How much storage your indexes are taking, if there is any index fragmentation and stuff like that, right? So that is another depth feature that will be coming in. Plus also around storage monitoring, that in case of SQL Server, data files monitoring, in case of Oracle, table space monitoring and stuff like that. So, but tying it again back to now going from not just wide DB type support, not just more depth to the troubleshooting, to those individual database types, but also tying it back to the overall observability platform. That's where correlation comes in, as we discussed, plus also can we alert on some of these more proactively around queries, like around query slowness, doing baseline benchmarking and stuff like that, plus also correlating with some of the cloud data that's coming, right? So it's like basically you'll see a lot more of these as we kind of expand, right? And again, better with AI, right? How can we leverage AI to be better at database monitoring, database troubleshooting, and into the observability, right? And it goes back to what we observed, that it's not really to start with. Troubleshooting is not just done by directly DBAs, right? It starts with people who don't really understand, uh, who don't really have, not like they don't understand, but they don't really have that much depth or domain knowledge to kind of, like do it further. That's where that's what AI augmentation is, right? It's not just automation, it's augmenting the knowledge that we don't have, right? And to be honest, on our side also, we are using AI to kind of understand a lot of these, like index utilization monitoring, right? So it's all about augmentation. So that's what you'll see a lot more of these on our, on our future releases.
That's cool.
Yep.
I think it's always so ironic that we build these really rich interfaces with all this rich information, and now we can get to the point where half the time you may never even need to look at it because AI will take all of that insight, summarize it perfectly, and give you that sort of easy button to get to the end without having to leverage all this stuff we put all this hard work into. But of course, if you don't have those insights and you can't summarize them and make them action.
Yeah.
So cool stuff. All right. So we're going to get to questions here in a minute. Looks like we've had some really good, robust question activity come in. So I really want to appreciate that. But I, want to wrap it up by saying again, database issues, don't live in a vacuum. They're part of your applications. They're part of your infrastructure. They're part of your user experience. And tool sprawl and siloed teams are costing you money. They're costing you time. They're costing you morale. With Splunk Database Monitoring, we can change the game by unifying your entire stack, from the application trace all the way down to the specific line of code. With AI native troubleshooting and full stack correlation, you're no longer just monitoring, you're mastering performance. So don't let your database remain a black box. We want you to take the next step, talk to your account team to start a trial or book a custom workshop. And that way we can all work to build a more resilient future together. So yeah, let's kind of get into some of the questions here. Here, do we still have a Q&A slide?
Yep.
Yeah, awesome. You want to start with first in, first out? I've got
I think we can start with that.
was asking.
Yeah.
Rajesh uses Splunk infrastructure monitoring, and to use the database monitoring, is it a separate OTel agent, or it will be the same agent for infrastructure monitoring?
Yeah, that's a good question, Rajesh. And I think, so it's the same agent. It's the same OTel receiver that you might be using. I'm not sure if you're using SignalFX or Smart Agent receivers, but these are the OTel receivers that you'll be using. But there's a different licensing for this. It's because all this data, database monitoring data, is very high cardinality, and we need a different way to store it and not just as metrics, which is why, to make it easy for users to use it and not worry about cardinality, we had to kind of, add a new licensing system for this and a new SKU for that one. So it's the same agent, same receiver, but you'll need to do not a lot, but you need to do, you need a different licensing for this one. So.
Good. I'm glad you pointed that out. I should have called that out earlier. Speaking of which, a good follow-on question is from Kurt. Kurt wants to know what features or abilities of Splunk are native to AliCloud versus what's to be gained with the addition of Splunk Database Monitoring. Can we kind of separate those out?
Yeah, I think I would like to follow on. Maybe Kurt, you can specify a little further. It would have been much better if you were only looking like interactive, but I don't understand your question fully. Maybe Dave, do you understand the question?
So the way I read
completely?
It is, without database monitoring, you can do APM troubleshooting. You can find a slow trace. You could say the database is responding slow, but you don't know why. Right? What the database monitoring, I believe, is giving you is deeper insight into why is the database responding slowly? How is it, impacting other systems? Is it, is it the query itself? Is it the SQL
Yeah.
query? Is it underlying database or underlying infrastructure? I think those are all the things that sort of come with the new database monitoring capability, as opposed to today, you could still have an application problem. You can still probably track it to the database, but you're going to have to call in a DBA
Yeah.
or somebody else to figure out why it's slow. Is that about
Sounds
accurate to you?
Yeah, sounds good. I think I now I understand the question. I think Kurt has also like sent a new question to clarify.
Oh,
So I
yeah.
think I think the answer, Dave, that you gave is absolutely right. Right? It's not so with today it's observability cloud. You have APM, you have IAM, you have TEM. So with APM, you get understanding of, as Dave mentioned, around application slowness, and with slow traces, you can identify, oh, there's a slow trace because of a slow database span, right? So you can shortly detect a database slowness, but you cannot troubleshoot it further, right? So that's where database monitoring comes in. You can now go one step further, as Dave mentioned, from a slow trace to actually the slow query and see why that query is slowing down. And same from the IAM view, if you're using infrastructure monitoring to kind of alert or track database infrastructure metrics, right? As Rajesh also mentioned, you can alert on, surely you can alert on database CPU, database, maybe disk or memory and other things. But you to troubleshoot those further is, okay, why is my database CPU spiking? Why is my database memory spiking, right? So that's where you troubleshoot. To troubleshoot that further also, you can you need database monitoring. So the way I kind of explain it is, as they mentioned, is APM and IAM help you detect database monitoring issues, but to troubleshoot those further is when you need database monitoring. Otherwise, there's a lot of manual scripts and other things, right? So yeah.
Yeah, cool. Good one. So let's move on to Sunil. And I think we kind of hit it, but we can just kind of reinforce which database platforms that we support today, and then which ones are coming in the next few months.
Yeah. So the first one, the first part of the question, today we support Microsoft SQL Server, Oracle, and PostgreSQL. The next ones that we have in plan are MySQL and MongoDB. And then we have other things like, this is the plan for before, July, we'll be shipping MySQL and MongoDB. And I'm just taking that as a very buffered timeline. But yeah, beyond July, we also have, like DB2 on the roadmap, and, Cassandra and Couchbase as well. So, but the immediate ones are MySQL and MongoDB.
Yeah, good. All right, good. I think you kind of hit a lot of that during the roadmap section anyway, but it's always good to repeat it. Let's see, our next question from, I'm going to say Gagandeep, probably butchering that name, is, can we tell a little bit more about how licensing is calculated for the database monitoring?
Yeah, so we have kept it super simple, as at least that's what we believe we did, right? You don't have to worry about query amount. You don't have to worry about anything. All you need to worry about is how many database instances do you have. And the same database monitoring unit can be used to monitor either a PostgreSQL instance, an MS SQL instance, or a MySQL instance, or any other DB type that we launch in the future, right? So it's basically, if you have 100 database instances, no matter what type, if we support those database types, you just need 100 units. So
that's good. So you don't have to buy licenses for each individual database type. That's good.
Yeah, it's not like you need a separate license for PostgreSQL, MySQL. There is one database monitoring license. You can use it to monitor any instance, and the metering is per instance. So if you have 100 instances, you need 100 units.
Yeah, nice.
Yeah.
And that kind of bleeds into Paul's questions about, is there an extra license cost? And there is an extra license cost. We're kind of looking at database monitoring as, a peer to APM, application performance monitoring, and infrastructure monitoring, and end user monitoring. Now we have database monitoring. So it's an additional license.
Yeah, it's an additional license, and you can reach out to, I would say, and I'm not sure if there is a way for me to maybe share my email, but Paul, reach out to your, account rep from Splunk, and let's set something up, and like they can give you more details around pricing and stuff as well, for not just for Paul, for anyone on the call. So yeah.
Yeah, awesome. That's very generous of you. So I'm really impressed by the number of questions we're getting today.
Yeah.
Raghav says, hey, great session. He wants to know if the AI recommendation feature is available today, or is this something that's planned for a future release?
Yeah, so the AI recommendation, Raghav, if you're talking about the query rewriting feature that we showed in the demo, that is already live. It's behind a feature flag, so you have to, we have to enable it for you, because we are trying to just keep it a little bit under the wraps and try to test it. So, but it is GA. It is available for you to use, and the AI SRE, or the summarization part, is still in the works. That's not available yet.
Awesome. Let's see. I see we had another question about licensing that I think we've kind of already hit there. So I'll skip to that one. But let's go on to the next question. I'm going to say Kathandaraman. Does that sound right? Can the AI recommendation engines be used as a payload for incident tickets? Can you use that?
Yeah, that's a good question. I think there are two parts to it. If you mean that, can we add those recommendations to the alert payload today? Not yet, but I think would love to understand a little bit more around this. Like maybe, you also reach out to your Splunk account team, and, or maybe I can share my email somewhere, but would love to, understand a little bit more about the use case there. So, yeah, but today you cannot have it as part of the alert payload, but we are working on something when the AI SRE sort of comes in, right? That summarization feature, then you can kick off the troubleshooting or the summarization or the recommendations from the alert itself, but it's not part of the payload.
Yeah, that's a cool suggestion. I like it.
Yeah, yeah.
Let's see, where are we now? Derek wants to know, he didn't see how the tool sends alerts. Might you be able to speak to how the alerting system works?
Yeah, it's similar to, maybe I can quickly show, if that's okay.
Yeah.
Chrome tab. Yeah, so alerting is common to how it works in the Observability Cloud. I'm not sure if you already use Observability Cloud, but the way to set up alerts is somewhere, you go to detectors, and you can create a detector here. And today you can create a detector on, let's say, give it test detector detection, whatever, right? So let's create alert. You can set up alert condition. You can select the metric, right? In case of SQL Server, right? So you can see the metric that are coming in, log weight count, database count, and stuff like that. So you can create alerts on this. One thing that we are yet to add to this one is alerting directly on query performance metrics. So today you can surely alert on instance metrics, but one thing that we'll be adding here is also for you to alert on the query performance directly. So yeah, that's the way. It's common to this. It's not specific to database monitoring because we are part of the platform ecosystem. So it is the same workflow.
Excellent. Next question, do we need to deploy an agent on the database server?
Yeah, not necessary. So the way it works is, these are actually OTel receivers. Like for SQL Server, there's a SQL Server receiver. For PostgreSQL, there's a PostgreSQL receiver. All this sit within the realm of OTel collector. If people on the call understand the OTel terminology, right? It's basically that it's a collection of different probes, if you will, and you can configure those. So one OTel collector can monitor multiple database instances of database types that we support, right? So you don't need to deploy OTel collector on each database instance individually. We rather recommend you to run it centrally and configure that same OTel collector to monitor multiple database instances. That way the configuration is much easier to maintain. But you can surely deploy that on the database instance as well. But that's a lot more tedious.
Nice. Here's another question from Derek. Does the database monitoring tool, does it monitor other aspects of SQL Server, like report server, analysis, services, integration services?
Not today. That's where the depth component sort of comes in. So it's our first iteration or first release, right? Our focus currently has been the most common issues like identifying the slow queries and troubleshooting those. But surely, Derek, I think on our roadmap, we would love to consider a lot of these as well, right? I think starting with even the jobs and other things like SQL agents and SQL jobs. So I think that is something that also, and of course report servers and other things. But there might be, don't quote me on this, but there might be some Prometheus or other receivers out there that might be doing it. So if you want to do it, you can send that as custom data into the observability cloud, because we support custom. If you have custom metrics, you can send that data in, but we don't support it officially
Yeah.
yet.
But that is one of our strategic pillars is deeper, more granular data.
Yeah.
It's good that something we can watch out for. We might have answered this already. Do you need a separate license for each tool in SQL Server?
Yeah, I think this is a follow-up to the previous one as well. Like currently, it's a little too soon for us to comment on that, Derek. But you don't need you need just one unit of database monitoring to monitor SQL Server. Once we add support for SSIS, RS, and others, I think we'll have to revisit that then. But it's a little too soon for us to comment on if it'll require a separate license or no.
Okay. Yeah, I'm glad we're thinking about it. Let's get in one more question. We can kind of wrap it up. Can we use a single collector to monitor both the application and database, or do we need to use a dedicated collector for each one?
You can use the same, Sunil. So I think that's one of the beauty of OTel collectors, that you can, monitor your entire stack from the same one. So yeah, you can use the same OTel collector.
Yeah, fantastic. Wow, I'm surprised. I'm pleasantly surprised we were able to go the whole hour. I appreciate everybody's interactivity here. But we don't really have to stop today, right? Because we have our community site, community.splunk.com. And there's a lot of ways that you'll be able to interact with us there. You can look for us on the community office hours. In fact, I think we are scheduling a community office hours for database monitoring in April. So keep an eye out for that. We also have Splunk Answers. So if you search for database monitoring, you can view and share best practices. There's a discussion section specifically dedicated to the tech talks. So this is where we will, if we end up getting more questions, we'll be able to answer them there. We'll be able to also post the video there. And then we also have a cool new ideas feature in the community. So you see something that you think would be great to add to this, you can go ahead and search and view and request enhancements through that mechanism, and that goes directly to our product management team. So that's pretty cool. And if you like some of the things that, if you like these type of webinars, we have a few new ones coming up. We've got a pretty cool one coming up next month on AI agents in Observability Cloud. And then another one shortly after that with AI-powered observability and observability for AI. That's one of the tongue twisters, right? Whether we're using AI to help you observe your applications, or whether we're using Observability Cloud to help you monitor your AI applications, your LLMs, your AI agents. So that should be pretty interesting in terms of breaking that down. So we are at the end of our session. We made it, the full hour. Akshit, thank you for joining me today. I think this was great. Thank you for everybody for coming and participating and showing your interest. As we've said, if you already have Observability Cloud, talk to your account team. Say, hey, let me try this for a little while. And we can give you a free trial. If you want to do more of a deep dive workshop, we can do that too. So let's keep the conversation going. And with that, I hope you guys have a fantastic day today. And
awesome.
I look forward to seeing you in the community.
Yeah, just a closing note, or just one thing to add. I think we got a note from our organizer that you have access to my email address. I think she has shared it with you. So yeah, please reach out. Feel free to reach out, and I think we can we can talk about the next steps or any questions you might have. So, but thank you for joining us today, and thank you, Dave. Thank you, Dianara. Thank you all.
Thank you, guys. Have a great one.